So today is day one of arithmetic sequencing. And we've been talking about sequences, we just didn't know it. When we were dealing with our domains, our discrete domains, and we had like 0 and 3 and 5. I don't know if we had anything like that. But this is a sequence, okay? It's just, and look at it, a list of ordered numbers is called a sequence. Some sequences are simply random values. However, most have a distinct pattern that is used to arrive at the sequence's terms. One such sequence is arithmetic sequencing. We'll talk about both arithmetic and geometric sequencing. And this sequencing part will be the second day of the test. It will be the Monday, I think that's the 21st, will be that test. If a sequence of values follows a pattern by adding or subtracting a fixed amount from one term to the next is referred to as the arithmetic sequence. I'll explain all this as always, but this is helpful to know. This is the background and the math behind it. The number added or subtracted to each term is called the constant. And the reason is because it's always the same. Okay, that constant is going to come in handy. This fixed amount or constant is the common difference, is what it's going to be called. It's the common difference. Now, difference usually means subtraction, but sometimes we're going to add and sometimes you're going to subtract. You're going to see here in just a while why we call it a difference. Referring to the fact that the difference between two successive terms yields the constant value that was added or subtracted. To find the common difference, subtract or add the first and the second term. Usually we're going to just subtract. That's the general way that this is taught, is you always subtract the second term minus the first term, okay? This constant common difference causes sequence to create a linear function. And we were just talking about linear function a couple days ago when we were talking about parent functions. And remember that root word is line, so it's going to be a line if we were to graph it. So now we're just going to find the common difference. So what I like to do is be very consistent on how I do it. So I always subtract. Okay, and I take the second term minus the first term. Now, sometimes you can just look at it and say, what do I do from here to here? So that's the reason they're saying you could add. What do I do to 10 to get to 14? Well, I add 4. And then I add 4. Okay, so that would be our common difference to add 4. So let me show you what I'm talking about here. If I take the second, and this is the part that I want to highlight, subtract the first term from the second term, subtract. So this is what it means that I can add from the first to the second. But you'll see in some of those other ones it might be a little more difficult. So if I take the second term, which is 14, I take 14 minus the first term, which is 10, I get 4. So that means I'm going to add 4 every time. And this one's really obvious. Why would you go through all this work? But some of these other ones, it might be helpful. So for instance, on B, we're going to take the second term, 3, minus the first term, -2. And when we subtract, we get 5, because we know that subtracting a negative is the same as adding its opposite. So we're going to get 5. So I would add 5. Is that true? 3 plus 5, 8 plus 5? Yes. Okay, here we go again. We're going to take the second term, -9, minus the first term. And when I do that, I get a -2. So does it go as -2 if I take -9 plus -2? Do I get -11? The other thing you also want to look at is if it's going up or down. See how these are getting larger in number? This one's increasing. This one is increasing. So notice I'm going to have a positive. And I go from this one to this one, I add 4. From this one to this one, I add 5. From this one to this one, I subtract 2 or add a -2. So this is on the decrease. But just notice those things to check your answers. Here we go again. So see how it's going down? You can look at this and kind of see how it's going down. But just to make sure, we can always subtract second term minus first term. We get a -6. Is it going down by 6? Yes, it is. That's the common difference. Now, there are two formulas that we use in order to write sequences. We have a recursive formula, and on the back side we have explicit. They both have their positive and negatives. The recursive formula is a formula used to find the next term of a sequence when the previous term is known. And that's the thing with the recursive formula. You have to know the previous term. Now, this is the recursive formula right here. That's a whole bunch of mumbo jumbo until you know what it is. These subscripts are really important and they mean specific things. So for instance, a sub 1, that means the 1 is the first term in the sequence. A sub 1. So just a side note, because it doesn't have anything to do with that. If I had, okay, so side note, if I had a sub 15, that would be the 15th term. That subscript tells you which term it is. It names its position. Okay, so that's a sub 15. So a sub 1 is the first term in a sequence. A sub n is the generic form for any term. So n, the nth term. And so if I wanted the 18th term, this would be a sub 18. If I wanted the 100th term, this would be a sub 100. Okay, that's the nth term. So the a sub n minus 1, this is really important. If I'm talking about a sub n, I want a sub n minus 1. So let's say a sub n is 12. A sub n minus 1 is a sub 11. This is the previous term. Excuse me. So a sub n minus 1 is the previous term before a sub n. It's the previous term for the one that I'm talking about. Okay? Then d is the common difference. And that's what we were just doing. If I wanted to find the common difference, I subtract second term minus first term. And actually, we could subtract fifth term minus fourth term. It just has, you have to take the previous term times the term in front of it, minus. So what we're going to be doing is we have to fill in this. We're going to put in whatever the first term is there, and then we're going to put in what the difference is. What is our common difference? So this nomenclature is really important, and you're going to see a lot of it. So the recursive formula gives us 2 bits of information. We have to know the first term. That's what this is, that a sub 1. And then we have to know what is the rule in order to give any term in a sequence from that term that comes before it. What is the pattern or rule, mathematical rule, that is happening to get any term in a sequence from the term that comes before it? Okay, the 2 things we have to find are a sub 1 and d. So for the sequence 3, 5, 7, 9, let's write the recursive formula. So recursive formula, I need a sub 1, and then I'm going to write a sub n minus 1, so the previous term, plus. So we are filling in this spot and this spot given this information. Well, the first term shouldn't be any problem at all. That's going to be given to us, or else we can't use recursive formula. So our first term is 3. Then we have to find the common difference. Well, you can kind of see what the common difference is, but just so that we get in the habit of it, we can take the second term minus the first term. So to find d, I'm going to take 5 minus 3. Could I have taken 7 minus 5? Yes. 9 minus 7? Yes. It doesn't matter which one. When I do that, I get 2. This is my recursive formula. Okay? So you're going to be asked to do that as part of your homework. Let's look on the back page, if I can get to it. So let's try a few more. Here we go. And at any point, if you want to pause yours and try it on your own, feel free to do that. So we want to find a sub 1, and a sub n is a sub n minus 1 plus d. Again, you don't need to put boxes around them. But I want you to realize those are the two things you have to find. So this is D, is what we're finding here. Okay, so a sub 1 given, negative 99. So we have to find D. D is a term minus its previous term. So negative 88 minus negative 99, cross the line and change the sign, that's going to give us 11. D is equal to 11. That's what goes there. That's all. Okay? So right now, pause and try this one on your own. Hopefully you've done that. So we're going to go a sub 1. What is that? A sub n is equal to the previous term, a sub n minus 1, plus d. Okay? I'm going to write that up here. A sub 1, a sub n is equal to a sub n minus 1 plus d. And d is that common difference. So a sub 1, hopefully you wrote down 7. D is 3 minus 7, so that would be a negative 4. So we go negative 4. Now, you might also write this as a sub 1 equals 7. A sub n is equal to a sub n minus 1 minus 4. Okay, so you can write that either way. Good. Again, try C. Why don't you just try it? Okay, so a sub n, we know that's 54. And D, remember we're finding D right here. We're going to take 45 minus 54. Sorry, can't do that in my head. I know I should be able to. 9. Okay, and it's a negative 9. So again, I can write either negative 9 or I can write that as minus 9. Both are the same. Okay, so now let's look at explicit formula. An explicit formula is used to find, the nth term. So this is really helpful if I want to find a specific term, okay? With the recursive, it's basically used to find the next term. I'm just going to keep on plugging things in to find the next term. The explicit one finds the nth term. Okay, so a sub n want the nth term, and they're going to tell us what term they want us to find. Or we're just going to write the formula for it. And then we need a sub 1 and we need the difference. So see, we need all the same things. So here we go. If we're going to write the explicit formula for this, a sub n is equal to a sub 1 plus d times n minus 1. A sub n is equal to the first term plus the difference times n minus 1. Because remember, we found the difference between 4. 5 minus 3 was 2. This was on the page before we found that difference. This is the explicit form, but we usually multiply it out. So a sub n is equal to 3 plus 2n minus 2. So a sub n is equal to 1 plus 2n. Okay? And sometimes people also write a sub n is equal to 2n plus 1. It doesn't really matter which way it's written. Okay, let's try a couple. Oh, the same ones we just did. So we already know the difference for this one was 11. The difference, and I'm just taking these from up top, this one's negative 4, and here my difference is negative 9. So let's plug it into a sub n is equal to a sub 1 plus d times n minus 1. Might not be a bad thing to memorize. We're going to plug everything in. A sub n is equal to a sub 1, which we know is negative 99, plus the difference of 11 times n minus 1. Okay, now we're just going to simplify that. A sub n is equal to negative 99 plus 11n minus 11. So a sub n is equal to 11n minus, why can't I do that without a calculator? 110. What this is used for is if I want to find the 15th term. Right now you might not realize why that's important, but we will see later on. Okay, we're going to do the same thing here, and we're going to do the same thing here. Okay, pause it and do this next one on your own. So how'd you do? Did you get a sub n is equal to, whoops, forgot the n, kind of important there. Okay, so a sub n, sorry about that, is negative 4n plus 11. Forgot the n on that one. How'd we do? Better than me, I hope? Great. Okay, C, if you want to do that same thing, pause. Okay, or you can just watch as I go through and do it. A sub n is equal to A sub 1, which is 54, plus the difference times n minus 1. So A sub n is negative 9n plus 63. Okay? Not anything real difficult, but if the more you practice, the better you get at them. Determine if the sequence is arithmetic. If it is, then identify the common difference. So on this assignment, you might have some things that there's not a common difference. So you need to kind of check to see, are these all an arithmetic sequence? Is there a difference from here to here that's the same every time? Is it the same? Oh. Okay. So check those out and see if it's a common. It has to be a common difference. And if it is, state what it is. Now these are telling you that these are arithmetic sequences because you're going to find the recursive and the explicit for each one of these, just like we've been doing. And just to make sure you're good at them, look at the back. Your teacher might change that assignment. Check with them. Great. If you have questions, you know where to find us.